Hello class. Today we're doing 9.3 input-output tables. Okay, now when we look at a table, we are speaking of basically a table graph where input X is on top and the values we input or we choose, and then output the result of the values that we choose. Okay, here we have a rectangle, and here it asks us to complete the table for the perimeter of the rectangle. Now we know perimeter requires us to know the value of all of the sides. So here this side would be 3, this side would be X, okay? And we know that we would add all of the sides, which would be 3 plus X plus X, okay? So therefore, what we have here is that we know we have 2 3's plus 2 X's. So this would give us 6 plus 2X, and that would give us the perimeter of this figure, okay? Now, from there, what we would do is use this equation. Now, we have created an equation. We would use this equation to find the output based on our input, okay? So let's take a look. If our equation is 6 plus 2x equals p, and therefore if our input is 1, then 6 plus 2 times 1 is equal to p. Therefore, we have 6 plus 2, which would give us 8. So the first output value when x is 1, y is 8. Or when our input is 1, our perimeter is 8. So let's take a look at the next one. 6 plus 2x equals p. 6 plus 2 times 2 equals p. 6 plus 4 equals 10. So now our value is 10, okay? So now you should be able to complete the rest of that to get an idea of how a input table works, okay? From there, it says write an equation that describes the function. We basically wrote one already when we said 6 plus 2x equals p, okay? And then it goes on to say use your equation to find the value of x for which the perimeter is 50. So then what we would do is we would say 6 plus 2x is equal to 50, okay? Then we will isolate our 2x, all right? Take 6 from both sides so that 2x is equal to 44. And then divide both sides by 2. And then x would be equal to 22. And that's how that would be done, okay? On the back side, okay, it gets into a particular function table that we're not going to address today. We're going to move on to the bottom of the page, okay? Let's take a look. On the bottom of the page, you see that we have a table. It says, work with a partner. I'm your partner, okay? It says, complete the sales tax table for each of the 4 cities, okay? So here, Madison, Wisconsin has a 5.5%, and so therefore you would multiply your 5.5% times the value here to get how much the tax would be. So that looks a little like this, okay? I'm gonna work up here. $20 times 5.50%. And in order to work with this, we would need to change this to a decimal. Remember, to get rid of the decimal point, we need to move it 2 additional spaces. So that gets rid of the percent here. And then we can multiply. We have a 0 here. Okay, this is 0, that's 10. And then here we move 2 places over. This is 0. I'm sorry, we start here, okay, this place. 1, 2, 3, 1, 2, 3. Here's our 0 here. This is 0, and that's 10. And so therefore, the Wisconsin, and when we add it, we have 0, 0, 0, 1, 1. Okay, how many numbers are behind the decimal point? 1, 2, 3, 4. 1, 2, 3, 4. So it's $1.10. Okay, for the tax for Wisconsin, and that's how that's done. Okay, when we look at Ann Arbor, Michigan, then we have $20, and this is times 6%. Remember, move it twice, so that's 0.06. We multiply, that's 0, that's 12, and it's 2 behind the decimal point, so it's $1.20 in tax for here. When we look at New Jersey, 7% is the tax. Remember, we're going to move this 1, 2, so we have 0.7 times the 20. When we multiply 0, and that's 14, and so we have 1, 2, 1, 2, so that's $1.40. Okay, and that's how those tables are done. You can finish those for practice on your own. I can almost guarantee you that you will have a question similar to that on your quiz or on your test. Now, for the homework for today, what you will be looking at is the 9.3 input table. Okay, you will be asked to complete each of the input tables. So let's take a look at these tables so that we can get an idea of how they are done. Okay, so let's take a look at this one. On number 2 here, it says write an equation for the function, then complete the table. So here it says the output, remember the output is our y. So the output, there's our y, is equal 5 less than the input. So therefore, remember that less than, it creates an equation that we want to work in reverse, x minus 5. This will make it 5 less than our input, okay? So this is our equation, okay? So now we have y is equal to x minus 5, okay? And so now we want to complete this based on the inputs values. So then when y is equal to 5 minus 5, all right, y is equal to 0, that's there. Y is equal to x minus 5. When y is equal to 7 minus 5, y is equal to 2, that's there. When y is equal to x minus 5, y is equal to 9 minus 5, so y is equal to 4, that's there. And when y is equal to x minus 5, when y is equal to 11 minus 5, y is equal to 6, that is there. Let's move forward to number 4. It says write an equation for the function shown by the table. Okay, so here we are. Here, when we have, when x is 0, all right, and then our y here is 0, okay? But we need to find out how does it change. So let's see. When we go from 0 to 3, that's plus 3. When we go from 3 to 5, that is plus 2. And we go from 5 to 9, that's plus 4. Okay, so then 0 plus 3 is 3. 3 plus 2 is 5. And 5 plus 4 is 9. That's interesting. Okay, well, let's see what kind of change we have here. Here, this is plus 6. Here, this is plus 4. And here, this is plus 8. So this increases. This is plus 6. This is plus 4. This is plus 8. So we don't really have any type of consistency. Well, let's look at the difference between the two. All right, this is 6 and 3. 3 to 6, that's half. Okay, 3 times 2 is 6. Okay, let's look at 2 and 4. 2 is half of 4. 2 times 2 is 4. Let's look at here. 4 is half of 8, or 2 times 4 is 8. Okay, so every time we multiply, looks like we have here times 2. Okay, from 3 to 6 is times 2. From 5 to 10 is times 2. From 9 to 18 is times 2. So then 2x is equal y. Okay? Well, let's check it. When x is 0, yeah, y would be 0. Okay? So let's look at it. 2 times 0 equals 0. Okay? When y is 3, 2x equals y. So 2 times 3, y is equal to 6. Yes. 5, okay. 2x, all right, equals y. So when 2 times 5 is equal to 10, and then when 2 times 9 is equal to 18. So that's the difference between the two, okay? All right, now let's take a look at number 6. For each output, divide the input by 4, then subtract 1. All right, so for each output, that's y, okay, you're going to, it's going to be equal to divide the input by 4. Input is x, divided by 4, and then you're going to subtract 1, okay? All right, so let's take a look. Let's see if it works for here, all right? So y is equal to 4 divided by 4 minus 1. So let's look at it. 4 divided by 4 is 1. Minus 1 gives us what? A 0. So that works out. Let's try the next one. Y is equal to 8 divided by 4 minus 1. So when 8 divided by 4 is 2, minus 1 makes y 1. Okay, so our equation is correct so far. So what happens when y is 2? All right. Well, let's plug that in. Okay, we're going to use this space down here. Y is going to be 2, right, equal to x divided by 4 minus 1. All right, so now let's take a look. First of all, we want to isolate x. So we're going to get rid of the additive inverse. Plus 1 plus 1. So 3 is equal to x divided by 4. All right, so to get rid of x instead of dividing by 4, we're going to multiply by 4. When we multiply by 4, we realize that x is equal to 12. So this answer is 12, okay? All right, let's look at the next one. And if y is 3, then we have our x that we don't know divided by 4 minus 1. So we're going to get rid of our additive inverse by adding 1 to both sides. 4 is equal to x divided by 4. Instead of dividing by 4, we're going to multiply by 4, and 16 is equal to x. And that's that value, okay? So those are your even numbers for your workbook assignment for this particular lesson. Now, let's take a look at your textbook to get more of a clear understanding of how this chapter works, okay? So this is chapter 9.3. All right, we're on page